Imagine standing at the edge of a cliff, staring into a void so vast it swallows light itself. Your heart races, not from fear, but from the sheer weight of what you're witnessing. A glimpse of the universe's end, not in some distant future, but right now, flickering on a screen no larger than your hand. This isn't a scene from a sci-fi blockbuster. It's real, and it's happening in a quiet lab where scientists have done something unthinkable. They've simulated the death of everything we know. Galaxies unraveling, the laws of physics dissolving, the very fabric of reality collapsing into a digital abyss. All of it contained within a chip so small you could lose it in your pocket. This is the story of a quantum simulation so vivid, so hauntingly precise, that even the researchers who built it can't shake the feeling they've peered into something far bigger than science. It's a story that begins with a question. What happens when we recreate the universe's final moments with such clarity that it feels alive? And what does it mean if we, ourselves, are staring into a mirror of our own reality? The journey starts with a truth that feels like a paradox. The universe, for all its infinite sprawl, stars burning, black holes devouring, galaxies spinning in cosmic waltzes, might have a limit. Not in size, but in something stranger. Information. Picture every star, every particle, every fleeting thought encoded as data, like words in a cosmic encyclopedia. Now imagine tossing that encyclopedia into a black hole. You'd think it's gone forever, consumed by an abyss that erases everything. But quantum physicists have uncovered something astonishing. The information isn't lost. It clings to the black hole's surface, a finite canvas where the story of an entire universe can be written. This discovery, born from decades of debate, suggests something mind-bending. The total information in our universe, from the birth of stars to the whisper of your breath, is finite, measurable, containable. And if it's containable, it's simulatable. This realization hit the scientific world like a thunderclap, because it meant that the universe, our universe, could, in theory, be recreated inside a machine. Enter the quantum computer, a device that doesn't just crunch numbers, but dances with the very rules of reality. Unlike the laptops and supercomputers we're used to, which struggle to model the chaotic beauty of quantum mechanics, these machines speak the universe's language. They juggle probabilities, entangle particles, and wrestle with the idea of parallel universes, where every possibility plays out in an infinite multiverse. To simulate a universe on a classical computer is like trying to capture the ocean in a teacup. The calculations spiral, overwhelm, collapse. But a quantum computer? It's like holding a piece of the cosmos in your hands. And in a lab at the University of Leeds, scientists did exactly that. They set out to model something called a vacuum collapse, a theoretical doomsday, where the very scaffolding of reality, space, time, the laws of physics, falls apart. What they saw wasn't just equations or abstract data. It was a vision of chaos, bubbles of space boiling, merging, tearing apart like a cosmic storm. It was as if they'd opened a window to the end of everything, and what they saw shook them to their core. The lead researcher, Dr. Eris Thorne, a man known for his unshakable calm, stood before the glowing screen, his face pale. He'd spent his career chasing the mysteries of the cosmos, but this was different. The simulation wasn't just a model. It felt alive, like a living, breathing universe unraveling before his eyes. He later described it as a house of cards, the delicate order of existence trembling under the weight of its own fragility. The team had expected to see patterns, data points, maybe a hint of cosmic truth. Instead, they witnessed something far more unsettling, a single bubble of new reality emerging from the chaos. This wasn't a glitch or a quirk of code. It was a digital echo of theories that have haunted cosmologists for decades, ideas like vacuum decay, where a tiny ripple in the fabric of space could grow, consume, and erase everything we know. The bubble in their simulation didn't just sit there, it expanded, relentless, swallowing the virtual cosmos with a hunger that felt almost personal. For the researchers, it was a moment of awe laced with dread, a reminder of how thin the line is between understanding the universe and being overwhelmed by its power. This wasn't just a scientific breakthrough, it was a philosophical earthquake. The team at Leeds had done more than simulate a cosmic catastrophe. They'd created a mirror of reality so vivid, it forced them to ask, where does the simulation end and reality begin? If a machine can recreate the end of the universe with such precision, what does that say about our own existence? Are we, too, just a flicker of code in a larger program? The questions hung heavy in the lab, whispered in hushed tones as the researchers grappled with what they'd unleashed. They weren't playing gods, but they'd built something that felt like it could rewrite the rules of creation. And as the simulation ran, its bubbles of chaos merging and dissolving, it wasn't just the end of the universe they were seeing. It was a glimpse of something deeper, something that made even the most skeptical among them pause and wonder. What if we're closer to the truth than we dare to admit? In a sterile lab, where the hum of machines blends with the quiet intensity of human curiosity, a group of scientists achieved something that felt like touching the edge of creation itself. They weren't chasing fame or glory, they were chasing the truth, the kind that makes your heart pound and your mind reel. With just 4 qubits, tiny specks of quantum magic cooled to temperatures colder than the void of space, they did the impossible. They recreated a slice of the universe's soul. Not in metaphors or equations, but in a fleeting, tangible moment where the invisible dance of particles came to life. They simulated the birth and death of electron-positron pairs, those ghostly twins of matter and antimatter that flicker into existence and vanish in the blink of an eye. This wasn't just a number on a screen or a line of code. It was a window into the quantum vacuum, the seething, restless heart of reality, where nothing is anything but empty. To the researchers, it felt like holding a spark of the Big Bang in their hands, a spark that whispered secrets about the universe's deepest truths. This experiment, conducted in a meticulously controlled quantum lab, was no small feat. Picture the scene: lasers pulsing with precision, ions trapped in a delicate dance, each qubit a miniature stage where the laws of physics played out. These 4 qubits weren't just mimicking particles, they were embodying the chaotic, beautiful rules of quantum field theory, where energy and matter blur into one. The vacuum they simulated wasn't the serene emptiness we imagine when we gaze at the night sky. It was a wild, untamed place, alive with virtual particles popping into being and vanishing before they could be caught. This is the quantum vacuum, a realm governed by Heisenberg's uncertainty principle, where the impossible happens every instant. Energy borrowed from nowhere, particles born from nothing, only to disappear as if they'd never been. To recreate this in a lab, to make the invisible visible, was like capturing lightning in a bottle. The researchers watched, breathless, as their tiny quantum stage mirrored the cosmic drama that shapes our reality. What made this moment so profound wasn't just the science, it was the feeling it evoked. Imagine standing in that lab, the air thick with anticipation as the data streams in. You're not just watching numbers, you're witnessing the universe's heartbeat, recreated in a machine no bigger than a book. The implications hit like a wave. This wasn't about smashing atoms in a colossal collider like CERN's, where brute force and billion-dollar budgets pry open nature's secrets. This was intimate, precise, almost personal. A quantum computer acting like a miniature particle accelerator, not by brute force, but by mimicking the delicate interplay of energy and matter. The team had taken a phenomenon once confined to the realm of theory, accessible only through equations or the rarest of experiments, and brought it into the light. They'd shown that the quantum vacuum, the foundation of everything we know, could be studied, manipulated, even understood, not in the distant reaches of space, but right here, in a lab, with tools we built. But this breakthrough wasn't just a victory for science. It was a doorway to questions that shake the foundations of what it means to be human. As the researchers marveled at their creation, a shadow crept into their thoughts. If we can simulate the birth of matter from nothing, what else can we recreate? What happens when our simulations become so real, so detailed, that they start to feel like reality itself? The philosopher Nick Bostrom once posed a question that feels less like theory and more like prophecy in moments like this. What if we're already living in a simulation, a reality so perfect we'd never know the difference? The idea isn't new, it's haunted thinkers for centuries, but now, with quantum computers painting pictures of the cosmos with eerie precision, it feels closer than ever. The Leeds experiment wasn't just about particles, it was about power, the kind that lets us play with the building blocks of existence. And with that power comes a chilling possibility. If we can create universes in a lab, who's to say we're not already characters in someone else's story? This question lingered in the lab, unspoken but heavy, as the researchers grappled with what they'd done. They weren't claiming to have created life or consciousness, but they'd crossed a line. Their simulation wasn't just a model, it was a reflection of reality so vivid it blurred the edges of what we call real. The quantum vacuum they'd recreated wasn't just a scientific curiosity. It was a reminder of how fragile our understanding of existence is. If a handful of qubits could mimic the birth of matter, what could 1,000 do? 1,000,000? Could we one day build a simulation so complete that its inhabitants, digital or not, might think, feel, dream, just as we do? The thought was both thrilling and terrifying, a spark of wonder laced with dread. The scientists weren't gods, but they'd glimpsed something divine, something that made them question whether the line between creator and creation was as clear as they'd once believed. The implications didn't stop at philosophy. The ability to simulate the quantum vacuum opened doors to practical revolutions. Drug discovery, once a decades-long slog of trial and error, could be transformed by modeling molecular interactions with pinpoint accuracy. New materials, like superconductors that could revolutionize energy, were suddenly within reach. Even climate models, those complex tapestries of wind, water, and heat, could be refined with a precision that might help us fight the ticking clock of global warming. But with every door opened, a shadow followed. If we can simulate reality this well, what's to stop us from simulating catastrophe? A pandemic, a financial collapse, a war, modeled not as crude predictions, but as living, breathing scenarios so real they could guide decisions, or worse, be weaponized. The researchers knew they were standing at the edge of a new frontier, one where the line between discovery and danger was razor thin. As the lab lights dimmed and the hum of the quantum computer faded, the team was left with more than data. They had a story of human ambition, of touching the untouchable, of seeing the universe's secrets laid bare. But stories like this don't end neatly. They spiral outward, pulling us into questions we're not ready to answer. What does it mean to hold the power to recreate reality? Are we pioneers, or are we playing with fire? The 4-qubit experiment was just the beginning, a single step into a vast, uncharted territory where the rules of science, philosophy, and morality blur. And as the researchers left the lab that night, they carried with them a truth as unsettling as it was profound. The universe they'd simulated wasn't just a model. It was a mirror, reflecting not just the cosmos, but the fragile, audacious heart of humanity itself. The hum of progress is deafening now, a crescendo of human ingenuity that echoes through labs and boardrooms, shaking the very foundations of what we believe is possible. Quantum simulation, once a flicker in the minds of dreamers, has become a blazing reality, driven by breakthroughs that feel like leaps into the unknown. Companies like Microsoft, with their 8-qubit Majorana chip, are crafting quantum systems so stable they defy the chaos of the subatomic world. Google's hybrid simulators, blending the raw power of quantum mechanics with the precision of classical computing, are tackling problems that once seemed insurmountable, and D-Wave, with its colossal 5,564-qubit beast, is rewriting the rules of optimization, turning science fiction into science fact. These aren't just machines, they're portals, letting us peer into the intricate dance of atoms, the birth of stars, even the alternate physics of universes that might never exist. But as we stand on this precipice, marveling at our own audacity, a shadow looms, a question that grows louder with every breakthrough. If we can simulate reality this well, what happens when the line between the virtual and the real vanishes entirely? The implications are as thrilling as they are terrifying. In the hands of scientists, quantum simulators are revolutionizing our world. They're mapping molecular interactions with such precision that new drugs could save millions, crafted not in years, but in months. They're designing superconductors that could transform how we harness energy, lighting the path to a sustainable future. They're even modeling the chaotic swirl of Earth's climate, offering hope in our fight against a warming planet. But power like this doesn't come without a cost. The Association for Computing Machinery sounded a warning that still rings in the ears of those who listen. Within 2 years, quantum simulators could become so advanced that they outstrip our ability to control them. Imagine a simulation so real, it could model a pandemic, not just predicting its spread, but detailing every cough, every choice, every ripple of fear through a society. Or picture a financial crash simulated with such accuracy that it could be orchestrated or exploited before the first stock falls. This isn't just about understanding the world, it's about the power to shape it, for better or for worse. Nowhere is this power more chilling than in the realm of warfare. Quantum simulators could become the ultimate weapon, not of destruction, but of foresight. Imagine a nation running a simulation so precise it maps every move in a conflict before a single soldier steps onto the battlefield. It could predict the psychological toll on civilians, pinpoint a country's weakest infrastructure, or calculate the perfect trajectory for a weapon we haven't even invented yet. This isn't about tanks or missiles. It's about knowing an enemy's every vulnerability with a clarity that feels almost unfair. The line between defense and offense blurs, and the ethical quagmire deepens. If a simulation can predetermine the outcome of a war, is it still just a tool, or does it become a blueprint for domination? The ACM's warning isn't just a technical alert. It's a plea for the world to wake up, to start a global conversation about a technology that could reshape power itself. Without rules, without restraint, we risk turning our greatest discovery into our greatest threat. Yet the shadow cast by quantum simulations stretches beyond geopolitics. It reaches into the very heart of existence. As these machines grow more sophisticated, they're not just mimicking physical processes, they're starting to echo the complexity of life itself. Scientists are building virtual ecosystems, modeling the interplay of countless variables, climate, biology, even the faint stirrings of decision-making algorithms that mimic primitive cognition. These systems aren't alive, not in the way we understand life, but they're beginning to blur the edges. Feedback loops that mirror the self-regulating dance of cells, pattern recognition that feels eerily like learning. These are the seeds of something new. And with them comes a question that keeps philosophers and physicists awake at night. Could a simulation ever become so complex that it births a kind of awareness, Not consciousness as we know it, but something emergent, something that feels real in every way that matters. The idea isn't that we're on the verge of creating sentient machines, but that we're inching toward a frontier where the distinction between simulation and reality might cease to exist. This is where the story takes its most haunting turn. If we can build a digital universe so vivid that its inhabitants, hypothetical or not, could think, feel, and question their own existence, what does that say about us? The philosopher Nick Bostrom's simulation argument looms large here, a specter that refuses to fade. He suggested that one of three truths must hold. Either humanity will never reach the point of creating such simulations, or advanced civilizations choose not to, or we're already living in one. The third possibility is the one that lingers, a whisper in the back of your mind as you watch these quantum breakthroughs unfold. If our simulations can mimic reality so perfectly, how can we be sure we're not already part of someone else's experiment? Our joys, our sorrows, our fleeting moments of wonder. Could they be lines of code in a cosmic program? The thought isn't paralyzing, it's humbling. It reminds us that for all our power, we're still children of the universe, reaching for answers in a darkness that's vaster than we can imagine. As the scientists at Leeds and beyond push the boundaries of quantum simulation, they're not just building machines, they're crafting mirrors. Mirrors that reflect the elegance of the cosmos, the fragility of existence, and the audacity of human ambition. These simulations don't just show us what's possible, they show us how little we truly know. They're not answers, they're questions, each one more profound than the last. What does it mean to create a reality so real it could be mistaken for our own? Where does the simulation end, and where does creation begin? And if we're staring into a digital abyss, marveling at its beauty and terror, are we seeing the universe or ourselves? The truth is, we're not gods, but we're closer than ever to touching the divine. Not because we're crafting universes, but because we're daring to ask what it means to exist at all. These quantum simulators, with their flickering qubits and endless possibilities, are more than tools. They're a call to wonder, to fear, to explore. They remind us that the universe isn't just out there. It's in us, in our questions, in our relentless drive to know. And as we peer into that uncharted ocean, one thing is certain. The deeper we go, the more we'll find, not just about the cosmos, but about the fragile, beautiful, audacious beings who dare to dream it.